find the limit if it exists. And we have the limit as x approaches infinity of the rational function 3x squared minus x plus 4 all over 5x plus 2x squared minus 8. Now remember, we had a trick here when we're taking a limit at infinity of a rational function. We want to divide the numerator and denominator by the highest power of x in the denominator, which in this case is going to be x squared. So if we do that, we end up with the limit as x approaches infinity of dividing by x squared. That gives us 3 minus 1 over x plus 4 over x squared all over 5 over x plus 2 minus 8 over x squared. Now we know the limit of a quotient is equal to the quotient of the limits, so we can split this up into two limits, one in the top and one in the bottom. So that gives us the limit as x approaches infinity of 3 minus 1 over x plus 4 over x squared all over the limit as x approaches infinity of 5 over x plus 2 minus 8 over x squared. And then we know that limits of sums and differences are equal to the sums and differences of those limits. So we can evaluate each of these limits one term at a time. So we've got the limit as x approaches infinity of 3 minus the limit as x approaches infinity of 1 over x plus the limit as x approaches infinity of 4 over x squared. And then all of that is over the limit as x approaches infinity of 5 over x plus the limit as x approaches infinity of 2 minus the limit as x approaches infinity of 8 over x squared. And then we can start evaluating this. The limit of a constant is just that constant. So we're going to have a 3 up there and a 2 down there. And then the limit of 1 over x, or 1 over x squared, both of those limits are equal to 0 as x approaches infinity, and multiplying by 4 or 8 or 5 doesn't change any of that. So the numerator is going to be 3 minus 0 plus 0. The denominator is 0 plus 2 minus 0. And we end up with a final limit of 3 halves.